You can see the explanation step by step that's in the notes for number 3. Now with number 4 we have 5 plotted lines. And with each of the lines we need to be able to plot the points. So if you take a piece of graph paper, some of the quadrille graph paper that looks like this graph I have on the board, and you plot those points. There's several points, there's what, 5 points or 4 points to plot. So with each of the points, the first one it says -1, 4. So the first letter is x. The first number is x, -1. So where x is -1 and y equals 4. So I go to -1 and then y is 4. That's that first point. The next point to plot, it says if x is -4 and y is 1. So let's go to x is -4, right here, and y is 1. That would be right here. The third one says if x is -5 and y is 0. So again, go to x, -5, and then y is 0 would be right on the x line. And then the last one says, and if x is -6 and y is -1. So we'll go to -6, and now we have to go y, -1. So it's beneath that line. So you need to choose the graph that has 4 points that they look like they connect, don't they? They do look like they connect. So it should be a line that looks something like that. And the only correct answer for that is going to be letter C. Okay, letter C is the graph that looks like what we just plotted here. Okay, number 5. On number 5, it says plot the equation for the graph. So again, we have a graph. If you look at the picture for number 5, the graph shows a line that crosses the y-axis at 7 and it crosses the x-axis at 7. So it's going to look something like this. Okay, so when y is 7, x is 0, and when x is 7, y is 0. Okay, and it's asking you to find the equation for that line. All right, well, one of the things I did, we could use the equation method, y equals mx plus b. We know the y-intercept is 7, so we know we could use that. But let's just use a little bit of logic here right now. Basically, looking at the graph, we know that when x is 0, this point up here, when x is 0, y is 7. And we know when y is 0, x is 7. So looking at those two data sets, 0 and 7, 7 and 0, all right, what equation would work for that? In other words, thinking about x and y. Like I look at 0 and 7, 7 and 0. 0 plus 7 equals 7. 7 plus 0 equals 7. So why don't we say x plus y equals 7? Okay? And see if that's an equation that would work for this line. Okay? Now, we could put this in a slope-intercept form, but you can see the answers are now written in slope-intercept form. If we put it in slope-intercept form, we would say y equals mx plus b. So the first thing we would say is, what's b? Well, b is positive 7. That's where it crosses the y line. What's m? Well, m seems to go down 1 and over 1 for every step going down. See if I go down 1 over 1, down 1 over 1, down 1 over 1, down and over, down and over. So you notice the slope is negative. It's going downward. And every time you take one step down, you go over 1. So the rise is -1, the run is 1. -1 divided by 1 would be -1. So our slope is going to be -1x, or -x. -x plus 7. So y equals -x plus 7. Now, you see the form that the answers are written in. if I move this negative x to the other side of the equation, what's the opposite of negative x? I add an x to each side. So that would cancel out, and that would give me x plus y equals 7. So you can look at your data set and say, okay, 0 plus 7 equals 7, 7 plus 0 equals 7, so then x plus y must equal 7. Or you could do it this way here. In either case, you're going to come up with an equation for that line.